Mars, the red planet, a cold, dry desert world. But was it always this way? Scientists are increasingly convinced that Mars wasn't always a barren wasteland. Evidence suggests a much wetter, warmer past, perhaps even with vast oceans covering its surface. This intriguing possibility has captivated scientists and the public alike, fueling our desire to unravel the mysteries of our celestial neighbor. The idea of oceans on Mars may seem like science fiction, but the evidence is compelling. We see signs of ancient rivers, lakes, and even possible coastlines etched into the Martian surface. These features, visible from orbit and explored by robotic rovers, tell a story of a planet where water once flowed freely. The implications are profound. If Mars did have oceans, it raises tantalizing questions about the potential for life beyond Earth. Did life arise in these Martian waters? Did it evolve into complex organisms? These are questions that continue to drive our exploration of the red planet. The Martian surface is a treasure trove of geological formations, hinting at a watery past. Dried-up riverbeds snake across the landscape, their sinuous paths etched into the red dust. These channels, some stretching for thousands of kilometers, are stark reminders of a time when liquid water flowed on Mars. We see deltas, fan-shaped deposits of sediment where rivers once emptied into lakes or oceans. These deltas, preserved for billions of years, provide further evidence for a substantial amount of liquid water on ancient Mars. Craters formed by asteroid impacts offer more clues. Some craters show signs of erosion, their rims smoothed and channels carved into their walls. This erosion suggests the presence of rainfall or even glaciers in Mars' past. The evidence is undeniable. Mars was once a much wetter place than it is today. The question is, what happened to all that water? To support liquid water on its surface, ancient Mars must have had a very different climate than the frigid, arid conditions we see today. Scientists believe that early Mars possessed a thicker atmosphere which would have trapped more heat from the sun, creating a warmer, more hospitable environment. This thicker atmosphere, perhaps rich in greenhouse gases like carbon dioxide, could have sustained liquid water on the surface for millions, perhaps even billions of years. This period of warmth and water would have been a prime opportunity for life to emerge, much as it did on early Earth. However, over time, Mars lost much of its atmosphere to space. This atmospheric loss, driven by factors like solar wind stripping and lower gravity, caused the planet to cool and dry, leading to the harsh conditions we observe today. The possibility of ancient oceans on Mars raises a profound question. Did life ever exist on the red planet? While we haven't found definitive proof of past or present life on Mars, the evidence for a watery past makes this question more tantalizing than ever. On Earth, where there's water, there's life. From the deepest ocean trenches to the driest deserts, life finds a way to thrive. If Mars did indeed have oceans, it's conceivable that life could have arisen there as well. Perhaps simple life forms like bacteria evolved in the Martian oceans. Maybe life on Mars was even more diverse, with complex organisms inhabiting its waters. The search for signs of past life, be it fossilized microbes or chemical signatures, is a major focus of current and future Mars missions. Over billions of years, Mars underwent a dramatic transformation from a potentially habitable world to the cold, dry desert we see today. The key to this transformation lies in the loss of Mars' atmosphere. Unlike Earth, Mars lacks a global magnetic field. This magnetic field acts as a shield, protecting our atmosphere from the constant bombardment of charged particles from the sun, known as the solar wind. Without this protection, the solar wind gradually stripped away Mars's atmosphere over eons. As the atmosphere thinned, the planet cooled, causing liquid water on the surface to freeze or evaporate into space. Other factors, such as Mars's lower gravity and volcanic activity, might have also contributed to its atmospheric loss and subsequent climate change. Section 6. Whispers of Water, the Search for Present-Day H2O. While the evidence for ancient oceans on Mars is compelling, the search for present-day water continues. Though the surface is now too cold and thin-atmosphered for liquid water to exist for long, scientists believe that water ice might be hidden below the surface. Indeed, data from orbiting spacecraft and landers have confirmed the presence of water ice at the Martian poles and even in the soil at lower latitudes. This subsurface ice, protected from the harsh surface conditions, could be a valuable resource for future human missions to Mars. Moreover, there's evidence of possible liquid water flowing seasonally on Mars. These flows, known as recurring slope lineae or RSL, appear as dark streaks on slopes during warmer months. While the exact nature of RSL is still debated, they could be signs of briny water seeping to the surface. Section 7, the Mars rovers, unraveling the Martian mystery. Our understanding of Mars has been revolutionized by robotic explorers sent to the Red Planet. These missions, equipped with advanced instruments, have beamed back a wealth of data revealing the planet's secrets in unprecedented detail. The Mars rovers, including Sojourner, Spirit, Opportunity, Curiosity, and Perseverance, have traversed the Martian landscape, analyzing rocks, soil, and the atmosphere. Their findings have provided crucial evidence for past water on Mars and continue to shed light on its climate history. These robotic explorers act as our eyes and ears on Mars, allowing us to explore this alien world from the comfort of Earth. They pave the way for future human missions, providing valuable information about the challenges and opportunities that await us. Section 8, Future Frontiers, Missions to the Red Planet. The quest to uncover the mysteries of Mars is far from over. Multiple space agencies around the world are planning ambitious missions to further explore the Red Planet in the coming decades. These missions include sending more advanced rovers, deploying drones to study the Martian atmosphere, and even returning samples of Martian rock and soil to Earth for detailed analysis. The ultimate goal for many is to send humans to Mars. Such a mission, while incredibly challenging, would mark a new era in space exploration, allowing us to study Mars firsthand and perhaps even establish a permanent human presence on another planet. Section 9, Mars, a window to our past and future. The exploration of Mars is more than just a scientific endeavor, it's a journey of discovery that has profound implications for humanity. By studying Mars, we gain a better understanding of our own planet's past, present, and future. Mars serves as a cautionary tale, showing us what can happen when a planet loses its atmosphere and becomes inhospitable to life. It also offers hope, suggesting that life might exist beyond Earth, even in the most seemingly barren environments. The quest to unravel the Martian mystery is a testament to our innate curiosity and our drive to explore the unknown. It's a journey that will continue to inspire generations to come, pushing the boundaries of human ingenuity and expanding our understanding of the cosmos.